So my name is Luca Weiss. I'm Android platform engineer at Fairphone. And also in my free time, I'm open source maintainer and contributor for several projects such as PostMarketOS, Linux kernel, and OpenRazor. And you can find me on Mastodon. So quick facts about Fairphone. So we were founded in 2013. We started as an NGO awareness campaign. You can hear about all of this quite a bit later at our the talk with Agnes at 2 p.m. But yeah, we do fair electronics, so mostly smartphones, but also some accessories for the smartphones and some audio products as of lately. Our head office is in Amsterdam, but we also have some employees in China and in Taiwan. And yeah, we have over 140 people working for us. So, what is Linux? The Linux kernel is a. Give me a second. Need to also see it here. So yeah, it's an operating system kernel. So it's kind of the basis between the hardware and user space. So kind of all of the applications and all of the system things that are running on the device. Linux itself is running on most servers in the world. So kind of most of the all of the web servers basically that are that you use daily. They're running Linux. A lot of embedded hardware is using Linux as the kernel, and also every single Android phone in the world. So over 1 billion devices are running Linux. Yeah, as I said, it kind of provides a layer between the user space and the hardware. So kind of there's also a thing called kernel space, but it's kind of the stuff or the code running in the kernel itself. But yeah, kind of user space is everything on top. Yeah, the Linux kernel provides also a bunch of like process scheduling, memory management, etc. But I'm mostly kind of talking about kind of the things that interact with different hardware components on the device, especially. So Linux on laptops is easy. You can basically take any laptop. You can take an Ubuntu, ISO, or any other Linux distribution, and you can basically install it and you can run it, and basically most of the things will work. There might be some gotchas here and there if the hardware is not well supported yet, but for the most part it will just work. You don't need like 1,000 extra patches on top of the kernel to have it working. But so why are phones complicated then? Well, so a lot of I think a lot of the reasons why phone hardware is quite differently and doesn't work as well basically with mainline Linux, so kind of the upstream version, is kind of extra power savings. So there's a lot of extra things that need to be done by the kernel to actually make the hardware work and to be able to talk with the hardware. So for example, there's a bunch of reset GPIOs, so kind of where you first need to toggle a GPIO, so kind of in high-low state, to actually be able to talk to the device. And on a laptop, basically everything that is on the device is already discoverable, for example, on USB or PCI. Yeah, of course, also there's kind of a lot of the components that are connected, they are not using like a standard protocol. So for example, on a laptop, you have a USB webcam basically that is integrated, and this is using a very standard USB protocol to talk camera. But for phones, all of this is quite a bit more kind of lower level, which is, I think, is also one of the reasons for power savings. There's not a lot of extra kind of more high performance chips on the system that draw a lot of power, but it's only kind of the main SoC that is handling these kind of things. Of course, there's also a bunch of extra hardware that isn't present on a laptop. So, I mean, touchscreens are a thing on laptops nowadays, but of course, you have vibration motors, sensors, a lot of cameras, extra random buttons, etc. And of course, with phones, you also need voice over LTE and a lot of other things for actually doing phone calls. And of course, also the 2G, 3G phone call things. So let's talk a bit about kind of the how the Linux kernel lands on Android devices. So Linux itself is being developed on kernel.org and being released there every couple of months. Most of you, or many of you, are running this on your computer if you have Linux installed. Then every year, one of these versions gets selected as an LTS, so a long-term support release. This gets supported between kind of 6 years and 2 years. They're slowly moving to a 2-year support model because of difficult reasons. Based on this LTS branch that is released upstream by kernel.org, Google creates an Android common kernel branch, the ACK branch. For example, an Android 11 5.4 branch. This is kind of the 5.4 kernel version meant for devices that are launching with Android 11. Then based on this branch that is created by Google, the SoC manufacturer takes this, adds some support for their SoC on top, and then finally the device manufacturer gets this code base and can put their device-specific changes on top of this. And kind of this also means, by the time a device launches, the kernel is already multiple years old, and is never really updated because while mainline and the LTS branches are moving forward, or the new ones are created, and also Google is really creating new kernel version branches. The SoC manufacturers practically never updates the kernel version for an SoC, so the device manufacturer can also never really update it. So let's look a bit about kind of the Linux kernel that is shipping on Fairphone devices. So with both Fairphone 1 and Fairphone 2, so devices launched in 2013 and 2015, we were running Linux 3.4, which was released in 2012. So already kind of, you see Fairphone 2 was released in 2015, the kernel version running on it was released in 2012. But we actually managed to get even up to Android 10 running on the device. Android 11 also, for example, in LineageOS would work. With Fairphone 3, I have some nicer numbers here. It is running Linux 4.9, which was released in December 2016. And on the Linux stable branch, kind of, so where there's some upstream maintenance happening, it became end of life in January 2023. So since then, we have to do more work to actually backport some patches to the kernel version. And kind of it's a problem here because with Android 13 it was still supported, this kernel version, but with Android 14 it's just not supported anymore from Google side, and they're requiring some new kernel features that are not present in the 4.9 kernel. And kind of the code that we got from Qualcomm, it's about 2.5 million lines of difference compared to the 4.9 version that's being released upstream, and it's about 18,000 commits. So this also shows kind of why it's basically not really possible for a device manufacturer to rebase all of these 2.5 million lines and make them work, because a lot of it is also patching quite core kernel subsystems, which of course change upstream also. With Fairphone 4, it's on the other device, it's kind of the same story, either kernel 4.19 or kernel 5.4. You can see the numbers are going down a bit in terms of how many commits and how many lines of code. But these are also actually excluding some external kernel modules, so the things they call TechPack and things like Wi-Fi driver. These are external kernel modules and are not actually in these numbers. But yeah, even for the Fairphone 5, which was released only a few months ago, the kernel is end of life in 2 years, because the kernel version was already released in November 2019. But this is what the SoC manufacturer provides, and this is basically what a device manufacturer has to go with. So yeah, there's of course, it's not great to run these old kernels. As I mentioned, AOSP is dropping support for these kernel versions sort of aggressively, because they're also kind of sick with supporting these old kernels that don't support any of the features that they want to use. Of course, if you're stuck on the same kernel version all the time, you don't get any new features, because Linux is getting a lot of great new features. Of course, if you're stuck on the same version, you don't get it. There's also some concerns about security, because if you're running the same kernel or a 6-year-old kernel, it's questionable kind of also how many people, even for the Linux stable branch that's being released, like how many people are actually running this, how many people are testing this, how many people are looking at this for security issues. I think most security researchers are looking kind of at the newest releases, because this is what is generally used, and don't really focus on the old ones. A problem also with the vendor kernels is that you can't really have 100% open source user space, because a lot of the kernel drivers are using non-standard interfaces, or some interface that only works with their specific proprietary user space counterpart. And also, because you can't have 100% open source user space, there's some concerns about security and privacy, because as an end user, you can't know what the code is actually doing. What's the alternative? Well, you can try and push the device support upstream into the mainline kernel, so to the newest version that is being released all the time. Kind of what laptops, what you're running on laptops. So how does the mainline kernel development look for mobile devices especially? So it's quite a good community of people working together. They're working on mostly smartphones, but also some other mobile devices such as tablets or even smartwatches. The community development, so kind of the groups of people, they are mostly grouped by SoC, so kind of the system on a chip. So for example, for the Snapdragon 410, there's the MSM 8916 group, where they're maintaining some extra patches that are currently being upstreamed or are still a bit work in progress, but generally working. So also some unfinished work, so where it's not ready yet, and also some hacks that might be needed for this specific, or for some devices there. But this is kind of generally what we call kind of close to mainline, so kind of where it's basically the mainline kernel, so for example version 6.6, the newest version, plus, I don't know, maybe like 50 patches, 100 patches, or something along the line, but kind of what is all the time rebased to the newest version. Yeah, this is also kind of how volunteer communities organize. Companies probably have a similar system, but I don't really have too much knowledge there. Except I know how I also do this kind of similar, kind of have a tree per SoC, because it makes it quite a bit easier. So let's look at the mainline support for different Fairphone devices. So we start with Fairphone 1, released in 2013. This is all of the device-specific code that there is. Basically, nothing works. You can get a shell on UART that's basically int. Not even multiple cores work, so only one core gets enabled instead of the 4 cores. But there was kind of a fun proof of concept to run mainline on this really, really old device. Fairphone 2 was kind of the device where I started in my free time doing some mainlining. So I started, I think, in 2017. Working on this. This was before I joined Fairphone also. So we have a good amount of features working on the latest kernel versions. So kind of UART, so kind of the very low level debug output and input. The power and volume buttons you can press and you get key events in user space. USB, internal storage and SD card. Touchscreen is working only with the new display module because there have been 2 different display modules with 2 different touchscreen ICs. So currently only the new one is supported in mainline. Notification LED, so you can see when you get a notification, for example. Wi-Fi and Bluetooth, the ADSP, which is kind of a co-processor for basically audio and few sensor stuff. But you can talk to it. There's not really much kind of open source user space that actually can talk to it. Modem is working, so in theory you can do phone calls, but as you see on the right side, audio is not working, so phone calls are kind of useless if you can't talk to anyone. Battery charger is working, so you can actually, when you plug it in, it's sort of decently put some current to the battery. Vibration motor, and you can kind of tell the device to reboot into the bootloader, which is also a special feature. Extra working functionality, we have display and GPU working. This is not upstream. I could probably upstream this, haven't bothered so far because this is also a bit tricky with the 2 different display modules, which have 2 different panels. What's more interesting, in my opinion, is kind of what isn't working. Audio, as I said, quite a lot of people have spent some time on this, trying to get it working, but haven't succeeded because of basically, I will talk about this a bit later. Battery fuel gauge, so you can't know how much percentage is in your battery, which is a bit annoying because you don't know if you're running it on battery, you don't know if it's going close to 0. Camera is not working, flash and torch LED. Sensors, which is mostly a user space thing. There has been some progress lately in the last year, but not working yet. And video and decoder, encoder, and IMMU is not working. For Fairphone 3, it's quite a similar story. We have a good number of features supported, so touchscreen, reboot reason, notification LED, NFC even. We also have kind of the similar functionality working, but it's not upstream yet. I'm currently also working a bit on this, and some other people in the SoC community are working on this. And to be honest, the missing completely section is also quite similar. We again don't have battery fuel gauge, we don't have sensors, we don't have the camera, we don't have fingerprint sensor, which is new on that device. FFmpeg, looking a bit better on kind of what is really fully upstream. Also, yeah, kind of with kind of what is in my own repository. It's kind of decent support. It works well enough, but yeah, again, on what is missing, I think by now you start to see a pattern. What is missing, and FFmpeg is actually sort of decent-ish. There's some new things working. For example, video decoding, encoding, the battery and charger status is working. And this is only 2 months after launch with the latest kernel version 6.6, plus about 100 patches. Most of them are currently being upstreamed. Some already landed in the upcoming 6.7 release, and I think some will go into 6.8. But yeah, I'm confident that a good chunk of this will actually go upstream quite soon. But yeah, in the missing completely section, we also see kind of modem. There's some issue there. Audio is not working, camera is not working, vibration motor is not working, NFC, fingerprint sensor, etc. So I think by now you kind of see a pattern. I would say kind of this the missing features can be grouped into 3 different categories. Kind of the ones where it was never really implemented in the first place, or no one really ever implemented this properly. So fingerprint, camera, sensors. This is not working on any device basically. For camera, there's a few exceptions. There's some features that are not really that are not very often implemented upstream by kind of these volunteers. So this includes audio and NFC, where kind of also the knowledge is missing for especially NFC and camera in the previous section. There's also kind of the user space is lacking, so kind of there's not really applications to use this with or even to test it with properly. This is kind of a problem, like the user space, the kind of the people that would work on, for example, a camera app, they don't have any phone that supports the camera stack. But the kernel people, they can't really make support for it if they can't really test it well. So it's also kind of a problem there. There's also a few complicated drivers which are super tricky to understand because there's a lot of magic going on there, which especially includes battery charge and fuel gauge. For battery charge, it's probably not that magic, but you don't really want to drive too much current to the battery and potentially have a safety hazard there. So people generally also avoid working on that. Kind of why these drivers are missing, I would say kind of some people working kind of professionally professionally full-time on this. They are mostly working on dev boards such as this, so this is a Qualcomm robotics board. And yeah, as you can see, this doesn't have a camera, it doesn't have a fingerprint sensor, it doesn't have NFC, it doesn't have a lot of things that a phone does have, and kind of what is also in my list here. At the same time, kind of the volunteers don't really have an understanding for, or it is very difficult to get an understanding for a lot of these topics without actually having the documentation, because the documentation is very confidential, and so normal people can't access it. Yeah, as I said, user space lacking integration, so this difficult to develop. And there's also easier topics to work on. So most people volunteering their time don't have infinite time, of course. So kind of, simpler topics such as getting the screen working are preferred compared to, I don't know, getting camera working, because what good is a camera if you can't display anything here? I've heard a few times kind of, I don't need all this fancy functionality like, I don't know, camera, etc. I just want a working phone. I want to have a phone call, I want to write some SMS, I want to maybe send an MMS because, I don't know. But actually phone calls are kind of one of the more tricky things technically, because you need you need the modem support, you need to talk to the modem, have all of this working. Speaker support, which is different from microphone support. These are normally 2 different ways to kind of do audio. But you also need all of the audio routing setup. So if you use a normal phone, you expect a lot of different things to work. You expect to be able to use the earpiece and the microphone normally. You expect it to put on speakerphone, where you then use the main speaker and a different microphone. Maybe you want to use Bluetooth headphones for doing a phone call. Maybe you want to plug in USB-C analog headphones or using the 3.5mm headphone jack. Or you use USB-C digital microphones. So there's a lot of different use cases that really need to be supported for kind of these things to work as someone would expect. And of course, this doesn't even cover voice over LTE and voice over 5G, which is a completely different topic, and emergency calls and whatever. And yeah, there's also random other functionality like Sim Toolkit and things that some people in some countries need because their provider does something with it. Yeah, it's a lot of things to get working. So yeah. So what is kind of the goal of doing this mainlining? So from our side, I would definitely say kind of longevity in any case. I mean, so we have problems at Fairphone with the old kernel, and switching to a mainline kernel, being able to update it would solve kind of this issue. And of course, we also wouldn't be stuck on this old kernel version. Currently, where we can, we are quite used to updating the Android part. So getting Android to a new version, so come to Android 13 or Android 14. But still, with the kernel, it is it is quite an unsolved topic for us. With actually having mainline, quite a few possibilities open up. So you're not tied to these proprietary binaries anymore that are needed for some functionality. You can replace them with open source user space parts. So for example, the GPU driver you can replace with Mesa and use FreeDrano there, and even have Vulkan support, etc. But you could also, for example, run Android with proprietary binaries. So for example, for camera, it is a very difficult topic because it's a very complicated thing to get the camera quality good. So kind of if you would reuse just, for example, the camera binaries, you would still have the rest open source, but still have basically keep some of the kind of better parts of the proprietary stack. And also with mainline, you can run some other Linux-based operating systems, such as Postmac or Mobian. Yeah, that's what I'm talking a bit. So kind of, Postmac, which is one of the projects I'm involved in my free time, is kind of the tagline is a real Linux distributions for phones and other mobile devices. It is a 100% open source operating system for phones. We don't reuse the Android parts because most of them are proprietary and are pretty bad code quality in general. We can support a lot of devices with this relatively easily, with minimal overhead, because most of the code that is in the distribution is quite generic across all of the devices. Because if the kernel provides a proper interface, a standard interface, then user space doesn't have to be adapted for every single Android or for every single device, because the kernel is already abstracting everything away, how it should be done. In Postmac, we use standard Linux components, so we use Pulse Audio, we use normal init systems, we use GCC for compiling, we use basically what you find on a laptop distro also. We're quite upstream first, so we try to upstream all of the changes that we're doing to all of the components. So with BlueZ, if we have some development there, we upstream it. And there's also kind of in this upstream first mentality, we are also collaborating with a few other projects such as Mobian, which is Debian for mobile devices. Currently, Postmac is mostly kind of for developers and for Linux enthusiasts, kind of for the people that actually want to run, I don't know, for example, Docker or Kubernetes on the phone, or do a lot of other random Linux things, have root on your phone, why not? But yeah. So what would mainline kernel mean for longevity of the devices? Of course, it would mean we could actually update the kernel and get rid of this old crappy version and go to a new version. If we were running on mainline, and actually we could also easier update to new kernel versions, of course, because it's just maybe, I don't know, I would say maybe like 100 patches. And of course, these are a bit easier to rebase than 18,000 patches. We wouldn't be hitting end of life of kernel versions, so here in this table, you can see kind of all of the stable versions that are currently being maintained with the end of life date on the right side. So of course, if you update, you don't have to worry about this because you can just update to a new version, and we get new features by doing this. Kind of the utopia that I would say for what I would and kind of my team would like is basically on Android device update the kernel version to a new LTS version, so long-term support release, kind of once it's released or a bit after, and then never stay on the old version, because why should you? So for third-party software, I think if Fairphone devices would run on mainline, Lineages and other Android ROMs wouldn't really have any problem with it because they can just update to the new kernel, update the user space binaries, and I mean they basically follow stock Android anyways. Shouldn't cause any extra issues. Ubuntu Touch can basically do the same. They use a thing called Halium, which is basically reusing. So Ubuntu Touch is also kind of a open source Linux distribution for phones. But they're actually reusing the Android parts, so kind of the Android kernel and some proprietary parts from it to get the hardware functionality working. Alternative operating systems like Postmarket and Mobian, they can get kernel support, so basically the device will start working with those quite easily. And even Ubuntu Touch, they could switch away from using the Android binaries, so with the Halium project, to actually basically also going a bit closer to kind of what Postmarket is doing. And even for third-party devices, if a specific SoC has good support upstream, getting new devices working is quite easy. So this is also kind of why Fairphone 5 is already working that great, because I didn't have to spend that much time on actually getting the SoC working, the base bits working, but actually was just focused on kind of doing the device-specific things. So even if another company were to produce a phone with the same SoC, they can somebody can just make it working relatively easily. So, kind of the future. From Fairphone's side, it's definitely an R&D project. We are seeing what can be done. In any case, I think we will keep hacking on something like this because it's quite interesting and quite good to see what can be done. I think I'm confident that support will get better over time. I've already seen. I mean, you've already seen even just the progression of kind of. Fairphone 5 is working relatively nicely, and old devices are not, even though the old devices have had a lot more development time on it. So SoC vendors and other component manufacturers are getting, I think, better. It is still far from perfect, but at least better, so we can see what's going on. But yeah, also kind of realistically, some components will never really work great. So for example, you can actually see Fairphone 2 with camera support. You can see it is, first of all, 90 degrees rotated. It is very green. I needed to set the auto, the exposure and the gain manually. There is basically, and you get some picture out of it. I mean, it looks like my room, kind of in a very messy state. But yeah, kind of, it is getting better. So Fairphone 5 is running fully GPU accelerated, everything there. And yeah, so far most of the work being done on these devices is actually not really writing new drivers. So it's not a problem about writing new drivers, but there are already drivers upstream. But every SoC needs to have a slightly different code paths for some components. So it's really just about adapting the existing drivers, making some changes to them, and kind of figuring out why the hardware doesn't really want to work in the way that it does. Of course, there's also some device-specific things like the audio routing, but phones are on the technical side or from a kernel side, they're quite similar. There's a few I2C buses. For the most part, the same components are connected to the same I2C buses. So it's not really too much variation from a kernel perspective. So once one device is working, it is quite a bit easier to get another device working. So how you can run mainline kernel, if you want to do this, you can install Postmarket, for example. Most devices that do have mainline, that have some amount of mainline support, do have a Postmarket port. Of course, also you can get started with mainlining. I started basically from zero. I had some Linux knowledge that's quite useful, but otherwise, you just kind of work on it, figure things out over time. I think by now there's quite a bit better documentation, also on the Postmarket wiki, that documents a bunch of this stuff, and a lot more people know about kind of the weird things that need to be done for this. Having access to secret documents, now working at Fairphone, is definitely makes things easier. So normally kind of, schematics are confidential data sheets and documentation. Schematics do make it easier kind of to build a device tree, so kind of this hardware description that the kernel needs, because some things are not really obvious from the way that the vendor provided kernel has this written. Data sheets do make it easier to write new drivers in case it's necessary. Also for schematics for Fairphone 4 and hopefully soon Fairphone 5, we actually have the schematics public, so anybody can look at them. Datasheets, yeah, as I said, they make it easier to write new drivers. There, it's kind of a mix between some are proprietary, some are confidential, some are actually public. So for a few components, you can actually find a datasheet online from the manufacturer. And also having access to some documentation, it does make things easier to understand. But nothing of this can really prevent you from learning about kind of making support for this. So for example, with the schematics, it makes it quite a bit easier to kind of, there's some regulators, so kind of power supplies that are getting triggered. They get a GPIO line in, so kind of a high-low, and some power in. And when the regulator gets switched to high, then a kind of a different voltage comes out the other end of the chip. And this is used quite a lot on phones. But kind of normally the way the downstream kernel interacts with this is not very obvious that there's actually kind of this hardware component on the board. And once you understand this, it makes it quite a bit easier to, it makes quite a bit more sense, and you can actually write a proper device tree description for the kernel. It is possible to figure this out without schematics, especially if you have some experience with this. But yeah, schematics are nice. Yeah, so what should device manufacturers do, like Fairphone? So yeah, we should definitely push suppliers, so Qualcomm, the NFC vendors, the component manufacturers, or our touchscreen vendor, to actually push their code and their drivers upstream. So we never really get into these giant forks of Linux kernel, so with way too much code there. Of course, yeah, you can also show that it's actually possible. Show the component manufacturers, show even Qualcomm, hey, this is possible. You don't have to run this crappy old version. But yeah, kind of somebody needs to start doing this. Schematics, as I said, they are quite useful, not just for making Linux kernel, but mostly for repairability. So kind of knowing where the different components are, so you can actually replace them and fix them. Some devices have them leaked from repair shops or something, so some random websites do have some lying around. But of course, having them public for everyone to see would be quite a bit better. And there's nothing there's nothing secret about the hardware, because basically all of the phones kind of work in a similar way on a schematic level. So I don't think there should be a reason for this to be secret. Pushing all the code that you can and make it kind of make it possible for people to dig through the code would be nice. For Fairphone devices, we are pushing as much code as we can to open source to our website code.fairphone.com. So for example, you can get the whole Fairphone 3 source tree. You can download it, build it yourself on your PC, and flash it to the phone. And you basically get the same or a very similar build to kind of what we ship with normal updates, minus some proprietary components like Google services and Whitewine. For some proprietary parts that are needed to run a device, we actually provide them as binaries, so you can easily get them into your tree. But at least the rest you can all build. For Fairphone 4 and Fairphone 5, we currently have a bit of a different code available there. You can look at it, but due to the way that the source tree is structured, you cannot actually build it, unfortunately. Hopefully this will change soon for Fairphone 4 at least. But yeah, at least until then, you can look at it, which is really nice. So yeah, and that's it. Thanks for listening, and time for questions.
Thanks for the great talk. Can you dual boot the Fairphone, like Fairphone 4 or 5, by putting an SD card with like post-market OS, and still boot have the ability to boot also on the original Fairphone Android OS?
So the closest you can currently get is kind of, so the Android devices, they have an A and a B slot, so you can switch between them from the bootloader. You could flash the post-market boot image to the B slot, and then you can boot from that one, and it can find the root FS from the SD card. And you can switch back to the A slot, and then the Android RAM disk starts and is loading the Android system, which is on the internal storage. This is working. Unfortunately, this also means kind of Android would override the other partition when it does updates. So kind of you would have to reflash the other boot image. You also cannot switch the slots from the bootloader, so you would actually need a PC or some other device to actually run like this fastboot set active A or fastboot set active B to switch between them. In theory, you can switch it from user space. So if you have a rooted Android phone, I think you can switch it from PostmarketOS. You can also switch it, but it would be a bit error prone. I know at least one device, they have implemented kind of support for switching the slot from the bootloader directly. And I know some people are using this to actually switch between them kind of without having an external computer. I can, one more thing. So we are kind of stuck with the bootloader that also Qualcomm gives us. We cannot really be very flexible. It's like actually booting the kernel from the SD card. Unfortunately, it's not possible. But so at least, kernel from the internal storage, it loads from the SD card. That works.
Yeah, thanks a lot for this work, for working in this direction. It's super useful for us. My question is whether or not you have ways to run Android application. I'm especially thinking about your bank application, which is now mandatory to validate online payments and so on.
You mean Android on like Android apps on PostmarketOS? On mainline. I mean, if you had an Android build with mainline, I mean, just the kernel is different. Wouldn't be a difference in that regard. I know banking applications like SafetyNet and APIs like this to validate that the device is actually running securely. This wouldn't be a problem with mainline because there's not really a difference. It's kind of just that it's a thing that the device manufacturer is kind of asserting that kind of this device or this operating system is secure. On PostmarketOS, you can run Android apps with a project called Waydroid, which is running kind of Android services in a container, kind of I think an LXC container. But yeah, when running directly Android on mainline, I don't see why it should be a problem. Except that once the device is working fully, which hopefully it might be at some point, it should be possible.
Thank you for your great talk. My question is. When you design a new phone, do you take in account the components that you know are well supported in a mainline Linux kernel? For new
I'm not involved in the hardware development process, but I think I can basically say no right now. From Qualcomm SoC side, we don't really have a wide selection of SoCs we can choose from. So we basically have to choose the one that fits the best. Unfortunately, most of the Qualcomm SoCs, especially, Linaro, which is a company working with Qualcomm, they're supporting the highest end SoCs kind of when they're released. So maybe you've seen the news, a month ago or something. Newest Qualcomm SoC was announced and was basically day one. They got some support they pushed some support upstream. Unfortunately, this is not happening for kind of any other SoC line that's not the high end. So kind of the Qualcomm has a lot of chips. Most of them are not supported. Fortunately, their chips are not too different, but they're different enough to need kind of this per SoC support. For other components, I think kind of the better path would be kind of to actually, as I said, kind of push component manufacturers to actually include this the support there. Because then also, of course, other manufacturers or other people with devices with the same component would then be able to use the driver without needing to resort to some other driver.
From my limited research, I found that some manufacturers, for example, Librem, Star Labs, PinePhone, and I think even some Pixel phones, have good support for Linux builds. And so my question is, are those devices using mainline builds, or are they using some quirks from PostmarketOS or whatever? And if they're using mainline, would it be possible to use such components from those devices in the Fairphones?
So both Librem 5 and the PinePhone, they are using, so Librem 5 is using the IMX as a chip from, I think, NXP. PinePhone is using an Allwinner chipset. So both not kind of chips that are commonly used in phones, in smartphones. So I think most kind of higher-end smartphones are using Qualcomm. There's some lower-end smartphones using MediaTek. Of course, yeah, Huawei, I think, has their Kirin chip line. Samsung has their Exynos. But for the most part, kind of any other manufacturers using either Qualcomm or MediaTek, because they are kind of the vendors that are doing smartphone SoCs. I wouldn't say both the Allwinner and IMX is not suitable for mobile phones, because it's working, and even the Fairphone 5 is running in theory an IoT chipset, so one kind of more destined for some embedded product somewhere. But it is actually also, I mean, they have the same feature set as kind of the very similar Snapdragon kind of more phone SoC that they have. But I think also for both PinePhone and Librem 5, I believe, for example, touchscreen, it still needed to add, someone needed to add support for it. Of course, with Librem 5, there's a bunch of people working full-time on this, so this obviously means it goes quite a bit better. And I think also the SoC was already supported relatively well upstream before they even started with the device. PinePhone, there's a community of people working on this. Pine64 itself is not working on any software support, basically, so they're just relying on community people. And there it's not a... So if you really just run the mainline kernel from kernel.org without any extra patches on the PinePhone, most things I don't think are working, because there's a lot of extra functionality being developed, kind of, also this kind of close to mainline mentality. But I think it's less being pushed upstream. So it's, even after, I think PinePhone has been out for 3 years now or something, and there's still a lot of things that are sort of working upstream, but not well, because support hasn't been added.
Yeah, so you already partially answered this question, but I was wondering about the bootloader situation. So Qualcomm has been known for like decades to be very aggressive in terms of like enforcing secure boot on the first stage loader. As far as I know, there's no real like U-boot support or anything like that. Do you know if like there's some effort in that direction, if someone's looking at that or working on that or anything like this? And if the secure boot thing is like still the same for the new chips, or if they change something? Or?
Yeah, so kind of in the Android boot chain, at least on Qualcomm devices, there's kind of 2 levels of signing and verifying, I would say. So kind of so there's the kind of the very first bootloader kind of in the boot ROM which can't be modified. This one, there's some e-fuses on the device, so kind of where a public key gets burned into the device, you cannot change it. And then the primary bootloader, the boot ROM, is verifying the next stage based that is signed on this, with this key. Then we get to the XBL, which is proprietary, and to the ABL, which is the XBL is extensible bootloader, ABL is Android bootloader. ABL is actually open source. It is built on EDK2. So XBL is kind of providing a UEFI environment, as far as I understand, and ABL is running on top of that. And then from this on, from the ABL, it's Android verified boot. The reason kind of why, or at least the way that it's currently done, is kind of all the primary or the early boot components are signed with this kind of by their OEM key, because there's not really any other way to kind of ensure kind of a trusted boot from kind of the beginning to kind of Android running. There's some work being done recently on getting U-boot support for Qualcomm devices. I think somebody at Linaro is looking at this. But it's also, I think, tricky there to kind of ensure kind of so phones are expected to be very secure by now, at least on a theoretical perspective. So it is expected that the banking app can kind of assert that the device is reasonably secure and has not been tampered with. And I think once you kind of start opening up the early boot chains, basically you can do whatever it want and can also pretend that it's actually secure. I think banks especially wouldn't like this, etc. I'm not exactly sure to what extent Google is requiring stuff like this. But yeah, kind of there's a lot of reasons there. I wish it was different because obviously, for example, even on the M1 MacBooks or M2, they have figured out a way to kind of be quite a bit more open with signing third-party operating systems, or where you can sign a third-party operating system and actually boot it in a secure way. The same, by the way, could be applied to iPhones also because it's the same chip. They don't do it there. I think it could also be applied the same way to Android phones, to Qualcomm phones. I don't know why they don't do it. Probably because there's not really, I guess, business demand or customer demand as in manufacturers really going there and saying, hey, we want this. Yeah, it's tricky. I wish it was different. Any more questions?
How much leverage does Fairphone have on manufacturers to force them to publish everything upstream?
Probably not too much, because we don't buy enough from them. So of course, if we were to buy, I don't know, 10 million touchscreen ICs, they would probably reconsider. I mean, so Fairphone is currently selling about 100,000 phones a year, kind of on plus minus. So it is not a lot for the industry. Of course, if you go to smaller manufacturers, they probably are more looking at this. But I think in general, I think most of these manufacturers just don't do it because they don't see any customer demand. So I think if you would show some customer demand, so kind of saying like, hey, you should upstream your driver, then they might actually just do it because then businesses are buying their products. But if the customers are happy enough with the other driver that they're supplying, they just don't do it because there's no financial reason kind of to do it. I think that's kind of the I guess if there's no more questions, thanks for listening. And you can see a talk by Agnes and me at 2 in the big room, I think. We are talking about Fairphone and some other, quite a bit more kind of what we're doing in terms of mining and everything there. Thanks.